Hello and welcome. We are honored to have you with us today for our latest in the webinar series, GIS for State and Local Government for Asset Management. My name is James Kelt. I'm with Geographic Technologies Group. I've been in the GIS industry for a little over 25 years, and I'm very excited about today's topic, GIS strategic planning for stormwater and sewer systems. We have an outstanding group of panelists today covering a wealth of topics relating to geospatial technology for public works. We'll have 4 presentations today. First up, we'll meet Mr. Jason Marshall with Geographic Technologies Group on understanding the importance of strategic planning. Secondly, Mr. Justin Patananan with the City of Tulare, California, will speak to us on the impacts of utility mapping for a new enterprise GIS. Also with us today, we will have Noah Golinko on leveraging GNSS technology for enhanced stormwater and sewer management systems. And then finally, Mr. Justin Proctor on strategic stormwater planning using AI mapping to improve infrastructure for resilience. So looking forward to those presentations. At the end, we will rejoin all 4 panelists for a question and answer session, so we can answer any questions that may come up. I'd like to start off by learning a little bit about you, our attendees. We have a short poll we would like for you to fill out. So if we can get an idea of where you're located and what discipline you're in your profession. So if you could kindly fill out the poll, we would greatly appreciate your feedback. A little housekeeping for today's presentation. The entire session will be recorded and will be available for your review very soon. Once it's processed, you'll get an email link on accessing the recording. Also, we encourage you to use the question and answer section of the Zoom call to post your questions. So at the end, when our panelists return all together, we'll review and answer as many of those questions as possible. So let's take a look at the results. Hopefully you've had a chance to answer the poll question. So a majority of us are from local government, so that's great. There are some state folks here with us as well, so welcome everybody. That's normal. We've seen that before on kind of the demographic breakdown. A handful there in the academia space, some in the GIS industry, and some others as well. Majority looks like almost 100%, 97% are located here in the United States. So, and then some abroad. So for those folks that are dialing in, it looks like it might be a little late for y'all. So thank you for those that took the time to dial in from overseas. The business sector looks like a majority, well, it's pretty evenly split. It looks like some public works folks, public administration and planning folks, some transportation folks. So yeah, great. That's always good to see a wide group attending these types of sessions. So appreciate you filling that out. Well, on behalf of our speakers today, I want to thank you all for taking the time to meet with us. We hope these sessions will be informative and educational. So thank you for each of you speakers coming in and telling us about your expertise in the space. I also like to thank our friends at Asset Mapping and Connect Me for their assistance in making today's sessions possible. So with that, let's get started with our first panelist, Mr. Jason Marshall with Geographic Technologies Group. Jason.
Great. Thank you, James. And let me share my screen. All right. Thank you all so much for being here today. My name is Jason Marshall, as James said. I'm the VP of GIS Operations at Geographic Technologies Group. We're a full-service GIS consulting firm specializing in GIS strategic planning for government across North America. Jumping right in, what we'd like to cover with you today is just a little bit about our GIS strategic planning methodology, and as well speak directly to you about how this strategic planning methodology can be applied to stormwater and sewer GIS data management for greater efficiencies in staff time in your organizations, as well as providing increased service levels to your communities. First off, just want to give you a little bit of an overview of our client base as it relates to strategic planning across North America. We've got numerous clients, as you can see, across the US and Canada. Just to give you a little bit of an idea of our footprint. First off, want to pose some comments to you around challenges, vision, and goals as it relates to GIS strategic planning for sewer and stormwater. To give you an idea of why we feel that GIS strategic planning for these utilities is of high value to you and your organizations and the work that you do. And just this is by no means a comprehensive list, but just to give you an idea of some things that can come out of a GIS strategic plan for these utilities are increased efficiencies around planning for maintenance of collecting and maintaining an inventory of assets as it relates to stormwater and sanitary sewer. You can create efficiencies and workflows associated with your preventative and reactive maintenance of these systems, as well as increased efficiencies around your public and private development, design, review, and construction that will either impact your existing utilities or require new utilities to be put in the ground. A big thing that I'm sure you're all very cognizant of as it relates to GIS data within these utility frameworks is network connectivity. We need to have that connectivity in place to understand where these assets are flowing, the sanitary sewer and the stormwater networks. And it can also create efficiencies and improve your capital improvement project planning. For instance, understanding where road maintenance may be occurring and where that might intersect where water lines are being put in could create some efficiencies with planning projects around road resurfacing and putting in water lines while that resurfacing is taking place. As it relates to stormwater, a few things of note here related to your NPDES permits and maintaining those. We need to know where our outfalls are as they're defined by those NPDES permits. We want to make sure that our field crews and our office staff have access to the GIS inventories, the data and solutions, whether that's through a web interface, through a web GIS portal, through the desktop solution, such as ArcGIS Pro, or perhaps it's a mobile solution with a field crew or a staff member in the field working with a web application on a tablet or a smartphone. We also have opportunities to increase efficiencies with stormwater spill response. If we have access to that stormwater utility information in the fields during a spill response, we can see where that spill might be entering an open water conveyance, such as a creek or a stream. And in relation to sanitary sewer systems, we can create efficiencies around our inspections of those sanitary sewer systems, the rehab projects associated with the sanitary sewer system, as well as tracking and managing our manhole overflow responses. In relation to business system integration with GIS, this is a very, very important area that I can't stress enough, and I'm sure many of you are well aware of the importance of asset management, integrating the GIS systems within your asset management system, or pulling data from your asset management system, your work order management into the GIS as well can provide high value for project planning, et cetera. Other systems such as CMMS and billing systems, integrating those with GIS can also provide high value. And there are many, many other systems that may be integrated with the GIS to provide value back to your staff and your communities through efficiencies in program delivery and service delivery. Just to give you a high-level overview of Geographic Technologies Group approach to GIS strategic planning, and again, can be applied to these utilities directly. We utilize what we believe are the 6 pillars that are required for a GIS program to ensure sustainability of that program and success. And the first pillar, pillar one, is GIS governance. This is the people component, ensuring that the proper lines of authority, communication across groups are creating an atmosphere where we have efficient workflows, as well as preventing silos within perhaps your divisions within your utility departments. The second pillar is GIS digital data and databases. As you know, if we don't have quality, well-groomed data, it makes it very difficult to build software solutions such as web applications on top of that and be able to trust that data to make well-informed decisions as it relates to that data. The third pillar that is included in our strategic planning methodology are procedures, workflows, and integration. This is a critical pillar as it relates to integrating those GIS systems with your asset management, work orders, et cetera, as I mentioned on the previous slide. And also the procedures and workflows are just as important as we need our staff to understand what the most efficient order of operations are to achieve the work that we need to achieve, and how the data can be leveraged within those procedures and workflows to make us more efficient. Pillar 4 is GIS software. This is where those web applications come into play. We have our well-groomed data, our highly accurate data, and we want to provide that data to the end users in a form that is most valuable to them, such as a web application that's showing them where open work orders are and what assets they're assigned to, or perhaps an application that is allowing a desktop application that's allowing some analysis to be done on the asset inventory to determine where perhaps funding for sewer rehab needs to be done in the following fiscal year. Moving to pillar 5, IT infrastructure. This is all of the network, servers, security as it relates to IT. It falls. So we need to have performance systems in place that are maintained by GIS and IT professionals to ensure that these systems are performant, and which will translate into giving our end users a better chance of adopting perhaps new solutions or the GIS in general. And last, but certainly not least, pillar 6, we have GIS training, education, and knowledge transfer. We need a well-trained, educated workforce on how to utilize the GIS data and solutions in order to ensure that we have adoption for the solutions, buy-in for the workflows, and that staff know how to efficiently utilize the solutions and the GIS to improve the services that they provide to your departments as well as your community. And what would a GIS strategic planning project look like? So our approach is to break a project such as this down into 3 phases for our utility clients. The first phase is our needs assessment and data collection component. And that phase is solely focused on collecting data and educating the workforce on how GIS can be leveraged to improve these programs and services as it relates to your utilities. We often, on the front end, run an online questionnaire where stakeholders will provide answers to critical GIS questions. So we begin to understand the existing conditions of the GIS and the data. We hold a kickoff. Then we move into stakeholder interviews, and the information that's collected up to that point enables us to benchmark the organization and the utility against all of the organizations across North America that we have performed these strategic plans for. We also perform gap analysis from this information as well as SWOT analyses. And this allows us to develop a GIS needs assessment for the utility. And We also can oftentimes provide a high-level data review to allow you to better understand the quality of your data. This isn't a deep level quality review, but it does enable us to give some estimates around perhaps cost for data cleanup and things of that nature. And I actually have a couple slides momentarily that will speak directly to what you may see from a data review such as this. And then we have phase two, which we move into the conceptual system design and recommendations. This is where we're taking all of the existing conditions informations from the online questionnaire and the stakeholder interviews, the benchmarking results, and we're making recommendations based on the 6 pillars that we went through on the last slide. And then we move into phase 3, which is the strategic plan itself, which includes a return on investment analysis that will give your executives and department directors information on why should we do this? What will we get from this if we implement these recommendations? This can often assist with helping you acquire your funding or securing funding for the implementation of the GIS recommendations. Then we move into the strategic plan itself, which oftentimes provides a 3 or a 5-year plan of tasks to implement those recommendations that came out of phase 2. And this also includes estimated budget numbers for those implementation items. And then finally, we wrap up with a presentation to all stakeholders. And as I promised on the last slide, I did want to give you just kind of a quick view into what one of these strategic planning data analysis exercises will result in as far as existing conditions and understanding the current conditions of your data. You can see here with this client, we have a sanitary sewer network that has some spatial accuracy challenges that we discovered, and we've got some metrics around that with the offsets. We've identified feature disconnections in this case, where a number of laterals are disconnected. Some manholes are orphaned and not connected to inlet or outlet pipes. And then we've also got some duplicate features and some missing attribution in this case. And then here we've got a water, sanitary sewer, and stormwater data results for the city of Tulare, where we were able to assist them, partner with them, and gather some metrics on the current conditions of their data as well. And then if we could just momentarily shift, we did want to take a few moments to discuss the ArcGIS Utility Network, or the UN for short. This is Esri's latest data structure for utilities. I'm sure many of you have been hearing information about this for a number of years now in the GIS community. It's becoming more and more prevalent as far as adopting and migrating utility data to the utility network in the last few years. And as I'm sure many of you know, the migration of your organization from legacy ArcGIS Desktop to ArcGIS Pro will also, if you want to maintain the functionality of network tracing, et cetera, you'll need to look into this utility network migration. And I include it here in this talk because we always recommend, and we believe it's best practice, to do a utility network migration plan, strategic plan for migrating to and implementing the utility network, should your organization find that it is of high value for you to migrate your existing data structure to the utility network. It is a more complex network and will require more resources and data. It is very much an investment that an organization needs to make if you are going to transition to the utility network. It does provide some additional benefits and value to you that is outside the scope of this talk today, but I do encourage you to look further into it. But did want to give you just an idea of what a utility network planning and migration may look like. For the planning itself, the project would kick off and then move into a utility data existing conditions phase, where a very deep level of understanding needs to and analysis needs to be performed on your existing data to understand the quality of that data, how is the network connectivity, and really what we're moving towards here is understanding the level of effort to clean the data up prior to that migration. And then we move into a data analysis, data assessment, and readiness, and we provide reporting out on the readiness of the data. At that point, we have a better understanding of the data cleanup requirements. And then we move into a workshop where we present all this information to you and we discuss with you and we make some decisions around the best level of implementation, because the utility network is not all or nothing. There are stages and levels to the complexity of it, depending on what your needs are. And then coming out of that workshop, and once those decisions have been made, we provide a step-by-step migration plan. And this is your blueprint for your migration that will ultimately result in a migration project that'll involve a design, a pilot project, the implementation and build of the utility network, as well as ongoing maintenance and support. And that concludes my talk today. And what I would like to do now is introduce Justin Patananan. He works for the city of Tulare, California, one of our current clients. And with that, I'll pass it over to Justin.
I'm just going to share my screen here and well, good morning and good afternoon, wherever you might be. My name is Justin Patananan. I am the GIS analyst here with the city of Tulare, and what I'll be covering today is the utility mapping within a new enterprise GIS resulting from a strategic planning. So as I mentioned, I'm for the city of Tulare, and we are located in Central California, equal distance between Los Angeles and the Bay Area. Our main, due to our central location, we are a central hub for distribution, and our main um, thing here is food production, dairy, and agriculture. We're home to Haagen-Dazs, Kraft, Nestle, Land O'Lakes. So distribution and agriculture is still big here. As a city government, we currently serve 69,000 people within a 23 square mile area within our city limits. Yes.
We're not seeing your screen if you're sharing it. Want to try sharing it again?
Yes. How's that now?
Yes, but we're seeing you want to go into full screen mode now. Go ahead.
Oh,
there you go. Looks good.
There we go. Apologies for that. So I'm with the city of Tulare, and we have 69,000 residents within a 23 square mile area, and our city oversees the sewer, stormwater, and water infrastructure within our city limits. With that said, there should be ample amount of opportunities for innovative GIS. However, prior to 2020, the city of Tulare's GIS was mainly done for support of public works and our planning departments by third-party and consulting firms. Our main layers was water, sewer, stormwater, zoning, and land use and boundaries. And the remaining data that we got for our city's GIS was through Tulare County, mainly our address points, street center line, and parcels. We had no GIS staff in-house, so limited GIS work was done in-house. Our existing GIS services are hosted Map applications and web applications were hosted on the cloud and created as needed and updated as needed by consulting firms. Now, when we look at our stormwater and sewers, there are two departments and divisions that mainly oversaw these two assets infrastructure. One was our Public Works Department, who is responsible for the operation, maintenance, expansion, and cleaning repair. And as far as GIS, what we found with the data sets was they were aged as much as 10 years and didn't reflect significant development and projects that occurred within the city. Our engineering division is another division that oversees our sewer and stormwater infrastructure. And what they're in charge of is plan inspection and plan review, capital improvement management, and long-range planning of these two assets. And once again, they relied on third parties to complete CIP design, as well as drainage modeling and provide us with GIS and CAD data. With the intake of data, there was a lack of processes and standards. So we had data with different schemas and fields and attribution. And once the GIS data was received, there was no central GIS within the city in terms of staff or place to put it or store it or display it. So it was mainly just floating around. The last thing that we saw, and one of the main drivers for this division for GIS was it was largely paper-based. And our engineering division used map books to look up utilities and as-built. So the process largely went as this. We would look up an area or an asset by looking at this index map and finding the location for the storm water or storm drain pipe or sewer asset that we're looking for. Let's say we're looking at sheet 1. Once they will go to sheet 1, they would try and find asset. Some of these maps, like this one, were in their original state and written on over time to bring the as-built to their current state. Once they would look at these sheets and find as-built, then they would go to the as-built, such as these, to provide information and collaborate with fellow staff members, as well as help customers. So you can see through this process, this was very timely, time-consuming. In addition, as-built were saved on network drive, isolated, and only accessible by the engineering division. So there was a need to bring this data, as-built and GIS data, into a more central location. So the city recognized that GIS was the way to go with these two assets, and there was a need for a strategic plan. And the need for a strategic plan was, one, motivated for the justification for growing GIS within the organization. Two, understanding the needs of the organization, establishing the potential of GIS within an organization, and building support throughout the organization. It required department involvement and established a timeline and a roadmap for success. So in the fall of 2019, the City of Tulare partnered with Geographic Technologies Group, or GTG. As Jason mentioned, the strategic plan involved 6 pillars of GIS sustainability. And this was largely a part of the first of 3 phases of building the strategic plan. The first phase was the assessments. As Jason mentioned, GIS governance. And this, when our organization saw that we needed more people involved with GIS within our organization, a steering GIS committee, a GIS user group, and what we've been lacking the whole time, GIS staff in-house. From that, we went to GIS digital and data and databases and recognized that we needed centralized data access and ownership, not just getting data from third parties, but also creating and maintaining our own data over time to ensure accuracy, as well as the data being current. From there, we went to system integration and maintenance, where we looked at workflows for maintaining data, as well as integration of other software such as Laserfish to help share information. From there, GTG looked at ArcGIS software and recognized the need for more software and more applications for our organization. Prior to our strategic plan, we only had one GIS desktop license, basic license, and then an increase for infrastructure. The need to share information required ArcGIS Online and the implementation of ArcGIS Enterprise. And once all these items were in place, was a continued education of how to use this GIS data and maps for our staff. Phase 2 was the conceptual alternative system design and revolved around a GIS software strategy, which mainly focused on eventually deploying an ArcGIS hub, which would serve as a central point for our GIS data and our GIS map applications that would help our staff. The other thing, as Jason mentioned, was a digital data assessment that oversaw the completeness, accuracy, and overall quality of our data. And the last step of building the strategic plan in phase 3 was the actual enterprise master plan, which showed us a 3-year process that started with an adoption and data creation phase, a second phase of deployment and implementation, culminating with a 3rd-year phase of full enterprise and GIS implementation phase. So applying this to our sewer and storm drain assets within the city, what we had were as-built such as this and what I've shown previously. And GTG took these as-built and georeferenced the data for our sewer and storm drains, and built out and filled in any missing attribution as well as any missing data. And the end result would be this. Now, once the data was complete, we needed a place to put it and share it with our staff. So we utilized ArcGIS Hub, not just only for our utility viewer, but also of other GIS applications that we would love to share with our coworkers. So this was then the result of our strategic plan, utilizing our ArcGIS Hub. And the utility viewer looks like this. So going from our searching for as-built and information from something that's paper-based to something that's digital through our GIS viewer, we're able to pull up the as-built in a more quicker and efficient manner, such as what I'm showing you here. So you can see it was done within minutes or less than a minute. So this was a capability that was greatly appreciated and valued by our staff in engineering and public works. And this was completed by migrating all these as-built from our network drive into Laserfish, and then completing an attribute expression that looked up our the as-built reference, allowing to search within our Laserfish and quicken a process that once took a long time for our staff. With that, I'll conclude that our staff recognizes now the importance of a strategic plan within GIS, and it not only has served as a roadmap to building our GIS, not just with sewers and stormwater, but also serves as benchmarks of our ability to head towards being a smart city. We've in this process has been very important in building a foundation for our GIS, and we're headed towards using this data for our CMS next year. So the potential is limited now. And with that, I will send it over to Noah Golinko with that elf. Thanks.
Yeah.
Yeah, for sure. It's still in the box right now, playing Saturday night.
Hey, how's it going, everybody? My name is Noah, and I am with Bad Elf. I'm a geospatial enablement specialist on our geospatial enablement team. I'm going to talk a little bit more about what that means coming up. So today in my presentation, I'm going to talk about why a digital system of record, which is sort of what was covered by the previous people that went in front of me. So I'm going to talk about more of the field aspect of it, what you can do with sort of the power of GNSS. So how do you get there? So my team is the Geospatial Enablement team. We were formed to sort of help state and local governments do deployments of GNSS and GIS in the field. So I'm going to talk more about that now. So we do have a little poll. If this isn't your first webinar, you'll know that we always do a poll at the start. This will give us some great data on who's attending. So if you do have time and aren't driving, we'd greatly appreciate it if you could fill it out. At the end of the day, everyone is at a different place when it comes to their geospatial journey. So we'd just like to learn a little bit more about how you're using GIS. So why create a digital system of record? A system of record is sort of a comprehensive database that serves as an authoritative source for information. So you can have things like your pipe networks, manhole covers, pump stations, catch basins, stormwater outfalls. You could have, this is actually one of our favorite pictures during our presentations. This is actually an opening up of the street in New York City. As you can see, there's a lot going on under the street in New York City. So it would be nice to have an accurate record of everything that's going on under there. So we always encourage people to record their new builds with high accuracy GPS so that you can have a centimeter level accurate representation or a digital twin of what's going on underneath streets and in sewer networks. So, you know, you can use GIS systems of record to create accurate and up-to-date maps of infrastructure assets. You can identify and prioritize maintenance needs. You can also do, as was mentioned before, you can do maintenance work orders within GIS, within ArcGIS. You can ensure compliance with regulatory requirements. Basically, you can just utilize GIS to analyze your spatial data and identify areas of concern, such as flood-prone zones or aging infrastructure. And then you can make informed decisions about your capital improvement projects. So what is the goal of an asset management system? It's to track location and condition, to minimize maintenance costs, to analyze data and plan effectively for the future. It's for proactive maintenance. It's for insights. So you can relate all of your data together and you can make powerful dashboards, as was shown by Jason. And you can improve your reporting and decision making, generating accurate, actionable reports for long-term strategies. You can ensure safer, more reliable infrastructure for the community. So what are some of the benefits? So you can do streamlined data entry. ArcGIS provides forms, manuals, reports. You can geolocate your pictures with high accuracy GPS. You can use arcade expressions to enforce conditional views on your asset collection in the field. You can do real-time data validation with domains and checklists. You can have synchronization. So offline functionality and field maps, you can actually collect data offline and then upload it to the cloud once you sync back with data. You can get GNSS metadata. So some of our GNSS equipment, it provides extra metadata into field maps. We actually work directly with the field maps team to provide that functionality. And then you have improved stakeholder engagement. So this is a dashboard. I did an internship at the city of Tempe, and I really, really have a lot of respect for their GIS team. So this is one of their citizen reporting tools. So you can see that they have all kinds of different things that you can report, and then it's, you know, geographically representative. So this is another one of my favorite graphics. This sort of shows the power of external GNSS. So phones and tablets are great for annotation. You can sort of move the crosshair around in field maps and select things and make annotated points, but they're not going to be super accurate. So if you see, we've got some bubbles here. So we've got storm sewers and storm drains, and a 15-meter bubble, which is what you're going to get on your cell phone GPS, is going to be good to get you to the area. But if you need precise asset locations, you're going to need a mapping grade bubble, which is somewhere between 2 and 5 meters, or a survey grade bubble, which is less than a centimeter, and that'll get you right on. Especially if you're like having to dig through snow, or if your assets are flooded, you need to know exactly where they are. So that's where high accuracy GPS comes into play. So this is we've deployed some of the stormwater asset inspection solutions from ArcGIS field maps, or from ArcGIS solutions to customers. So some of those key features: you can capture assets, you can expand and you can include environmental delineations, you can incorporate other solutions such as like sign management or other relevant data. You can include condition assessments and key attributes for all the features. But we always recommend to start simple. You want to keep your forms as clean as possible to sort of promote wide adoption within your agency. And we work with state and local governments to help race that along. So accurate location data enhances analysis quality, and then speeds up inspections, right? So like I mentioned before, there's the ArcGIS workforce. There you can geo-reference a location. So say a citizen reports that that something is going on with a manhole cover, and then they can say where it is, and then you can make a work order, and you can send a team out there, all within ArcGIS. So you want to use the right tool for the job. I mean, like I said, cell phone accuracy is good enough for like a citizen reporting tool, but then you would want to use RTK GNSS to get to the exact location. So as I mentioned before, you want to take a balanced approach. You focus on collecting the data necessary for the intended application, and then you want to avoid overcomplicating your workflows. Because we work all the time with agencies that have field technicians that have been in the field for 20 years, and you put a GNSS receiver and a tablet in their hand, and they don't want to adopt anything new. So we try to make things as simple as possible to make sure that adoption is well received from your field crews. So some of the technology advances, as we know, technology is advancing at a rapid clip these days, and ArcGIS and GNSS are starting to incorporate some of that. So since even cell phones are more accurate now and affordable and portable than ever, we can get better and better data from the crowd, right? So crowdsourced smartphone technology, is rapidly improving what we get from users. And then this accessibility is no longer limited to professional surveyors, right? We can put a device in your hand that'll get you survey grade accuracy with very little barrier to adoption. So what does my team focus on? We focus on training field crews, getting out into the field and showing the field crew exactly how to do things. And then we help you on the back end, where we create training materials. We have online training platforms, and then we help deploy ArcGIS solutions. So we can help, as was mentioned by my esteemed colleagues here. They focus on the computer side of it a lot, and then we focus more on the field side of things. So we do that with our GNSS receivers. We have a survey grade receiver, the Battle Flex, and then we have a mapping grade receiver. Both these receivers are capable of sub-meter accuracy. But basically, we focus on the complete solution. because we want to partner with you all the way downstream. And that's all I have. And I'm going to pass it to Justin Proctor from Ecopia. Thank you.
Thank you, Noah. Just gonna share. Perfect. All right, thank you, Noah. And thank you to everyone for tuning into today's event and sticking around to the end. I appreciate it. So today I will be discussing strategic stormwater planning, leveraging AI mapping to improve infrastructure and resilience. So I'm going to start the conversation off kind of just providing some background to Ecopia, explaining how and why we do what we do. And then later on, I will dive into some case studies. So although this slide is an animation, it paints a good picture in terms of what we're trying to do, and that's create a digital twin. This is something, a lot of people talk about, but digital twin, huge buzzword in the GIS industry right now. But this is not, a product that everyone is able to actually create. Geospatial data is the foundation of the future, especially this 3D data that we're looking at here. So all the layers seen are digital layers, and this is what we're trying to create. So once you have this digital representation of the Earth, a lot of very interesting analytics then become possible. So some of those use cases include determining where to place solar panels on roofs, helping municipal government manage infrastructure, assisting in 5G radio frequency propagation analysis, and supporting property insurance risk assessment. So our goal is to not create data for one customer, but to create data as a commodity that we create once and then tool it for many different users. And by doing this, we create an efficient business model. So these are some of the industries we like to dabble in. So you got your insurance firms, telecom, government, obviously, civil engineering, and NGOs as well. So what we're trying to do is create a fit for mapping or a fit for purpose approach. So we want to maximize the utility of the data input to reach the output that is required, being that high precision digital map. So we can operate on two different functions here. So we can either leverage the imagery that you guys might already subscribe to. I know a lot of municipalities have aerial programs in place, so we can leverage that imagery. But if you don't have, the most up-to-date data, then we can source that for you. We have relationships with Hexagon, Vexcel, and Nearmap. So we have all of their newest and best imagery off the shelf and ready to go. But the end goal is the creation of that vector map. So we are an AI company. We're also a geospatial services company that leverages the power of deep learning to extract data from imagery sources. So we recognize the importance of the human input, especially on the quality control side of things. So we guarantee that all of our products exceed 95% geometric accuracy, effectively meeting that of a GIS professional. So we have 3 layers of quality control to ensure we're hitting that 95%. If the data sets do not meet that threshold, then it gets fixed and retrains the model until we get that vector output that we're looking for. So the old saying, fast, cheap, good, pick 2. I'm sure you're all very familiar with manual digitization, as it's something you might have taken care of at one point in your career, hired somebody to take care of. When it comes to this approach, there's a high level of accuracy, generally speaking. The problems begin when you start dealing with larger areas, extracting more features. You run into those interpretation issues as well as the scalability issues. And then not to mention very expensive over long periods of time, paying for all those man hours to delineate all those features. Flip side of the coin there, you got automated softwares. Ecognition, great example of one of these. However, they're not the most user-friendly programs to use. They say it takes a PhD to be able to operate Ecognition. It is a rules-based extraction, though, so you're able to process large areas at a low cost, but you're not able to get those updates very quickly. So where does Ecopia enter the mix? So Ecopia is creating data sets that are guaranteed to be over 95% accurate. And when I say 95% accurate, our data produced is going to be higher quality than what you would have produced through a heads-up digitization approach. The data is normalized as it is a rules-based approach, so you're always getting that consistent output. And we will deliver the data to you in a very fast period of time, to say 4 weeks from the receipt of imagery. And municipalities struggle with updating consistent data, and this is something that we can bring to the table. So I just want to kind of stress or summarize the 3 points from the first half of the slideshow there. It's just the accuracy, the scalability, and the currency of our data. So now on to the fun stuff. So I have leaned on my good friend here, ChatGPT, to help define what a climate resiliency strategy is. So as per ChatGPT, a climate resiliency strategy refers to a comprehensive and integrated set of actions, policies, and measures designed to help individuals, communities, and ecosystems adapt and withstand the impacts of climate change. It involves proactive planning, risk assessment, and management aimed at enhancing the capacity of natural and human systems to cope with the changing climate conditions. So thank you for that, ChatGPT. I'm now going to dive into some case studies from municipalities across North America, showcasing how they leverage geospatial data to enhance their stormwater management planning. So the city of Jacksonville has long relied on geospatial analytics for stormwater decision-making. Their Department of Public Works leverages land cover data not only for planning and monitoring stormwater infrastructure, but also determining stormwater utility fees that help fund the maintenance of this infrastructure. So the city has found that keeping their detailed data up to date with a dynamically changing world was a time-consuming and expensive and manual task to do across their 370,000 parcels of land. So by partnering with Ecopia, the city was able to procure 21 layers of high-precision pervious and impervious surface land cover data in just over 4 weeks. And now the Department of Public Works has a reliable source of truth for land cover in the area and can spend time on actual analysis and planning instead of tedious manual feature digitization. So jumping across the country, King County, Washington is a prime example of municipalities using accurate, up-to-date land cover data to inform public sector decision-making across various initiatives. So to avoid relying on fragmented data sets with inconsistent quality, the King County GIS Center leveraged Ecopia-generated land cover data over a 2,300 square mile area. And in under 8 weeks, Ecopia delivered 16 detailed land cover layers encompassing all natural and impervious surfaces. So this high-quality data supports a wide range of county initiatives, including enhanced flood modeling, accurate stormwater assessments, wildlife restoration efforts, and climate action planning. Additionally, it aids in transportation planning and social justice projects, contributing to King County's efforts to improve everyday life for its residents. So the National Oceanic and Atmospheric Administration, NOAA, their Office for Coastal Management is responsible for supporting environmental, social, and economic well-being of the U.S. coast by linking people, information, and technology. So the agency's Digital Coast website facilitates this mission by providing land cover data to communities and organizations to leverage in their geospatial analysis. So keeping data up to date with a changing environment is critical in all locations, but especially in coastal communities that are increasingly susceptible to natural hazards. To equip these communities with the data needed for actionable stormwater analysis, NOAA provides high-precision land cover data through their Digital Coast website. And while a 30-meter resolution data sets were helpful for understanding land cover at a high level, NOAA partnered with Ecopia to produce a layer of 1 meter resolution for increased granularity. So with this more detailed data, coastal communities can now better detect change in land cover and develop hazard mitigation strategies based on up-to-date high-precision information. So green infrastructure and stormwater planning. So maintaining a high-precision land cover database enables communities to develop innovative stormwater management solutions that also benefit the environment and enhance quality of life for its residents. So for example, the city of Los Angeles required data to strategically place stormwater medians across its extensive transportation network. So the city's Bureau of Street Services leverages Ecopia's data on traffic medians, tree canopy, street trees, bus pads, speed bumps to identify optimal median locations that improve traffic flow, channel stormwater, and create functional green spaces. So these medians not only support stormwater management, but also serve as a community green spaces, contributing to a more livable and resilient urban environment for Los Angeles residents. Jumping back up to the Northeast, another municipality that relies on accurate impervious surface mapping is the city of Detroit. So as Detroit works to redevelop its landscape with more green infrastructure and accurately calculating stormwater utility fees has become more essential to funding vital public works projects. So to do this, the city needs precise, current, and comprehensive land cover data, something that manual processes struggle to keep up with in a rapidly evolving urban environment. So to address this, Detroit partnered with Ecopia to extract high-resolution land cover data from geospatial imagery, establishing an annually updated source of truth for impervious surfaces used in stormwater utility fee calculations. So with Ecopia's standardized approach for detecting and tracking changes year over year, the city can now confidently assess shifts in impervious surfaces to optimize their stormwater utility fee. So Detroit has uncovered an average of 2% annual change in land cover, equating to a discrepancy of about $5.6 million annually. So revenue that is now captured and reinvested to support stormwater and green infrastructure initiatives throughout the community. So the Southeast Michigan Council of Governments, SEMCOG, utilizes land cover data to support diverse mapping initiatives focused on climate resilience and stormwater management across a 7-county region. So SEMCOG oversees a wide range of geospatial projects, including green infrastructure planning, pedestrian safety, and traffic engineering, as well as flood management. So this agency needed 24,000 miles of sidewalks and crosswalks mapped to assess regional accessibility. And the partnership was eventually expanded to include comprehensive land cover data for more stormwater planning purposes. So today, SEMCOG leverages Ecopia's high precision map layers to help stakeholders better understand land cover and its implications for future flooding scenarios. And lastly here, flood modeling is a critical element of the Canadian city Peterborough, their stormwater management approach. So after a major flood back in 2004, the city intensified its focus on using geospatial data and mapping analysis to understand how land cover influences flooding and to better prepare the city for future flooding events. So like many municipalities worldwide, Peterborough faced challenges in maintaining a detailed and accurate and current data set in a rapidly changing environment. So by collaborating with Ecopia and consulting firm Jacobs, the city developed an integrated flood model based on a single consistent source of truth, containing high quality land cover data, which is updated regularly to reflect real world changes. So powered by a 2D surface mesh derived from Ecopia's land cover data, the IFM enables the city to model potential flood scenarios, strategically prioritize stormwater infrastructure projects, and build a more resilient community. And with that, I thank you guys. And like I said at the beginning, thank you all for tuning in today. And I will now ask my fellow presenters to come to the stage.
Well, great, everybody. Thank you for that. Looks like we had a great few sessions there, so I appreciate everybody taking the time to prepare their presentations. We do have some questions from the attendees today, so I'd like to just open it up to the entire panelist group. So Jason, Justin, Noah, and Justin. I'll try to target each question to the folks that I think they were asking them to, and kind of go from there. One of the questions was, can a return on investment be developed in a strategic plan to assist in funding the GIS? So why do we do it, right? I think that was probably to you, Jason Marshall there.
Sure. Thanks, James. So the short answer is absolutely. So the return on investment that I mentioned in the talk associated with the strategic plan phase 3 of our methodology is geared towards just that, to assist with communicating to either it could be potentially elected officials, or perhaps city manager's office, or perhaps board commissioners, those types of things as it relates to securing funding. In this case, for GIS programs associated with the stormwater and sanitary sewer utilities, but oftentimes that could be in the larger framework of securing funding for a GIS program, for instance, for a municipality, a portion of which would go to the utility components of the recommendations.
Perfect. Great. Thank you. Justin Patananan, I think you touched on something that is going to pique some interest with the group in georeferencing your Laserfish as-built drawings into GIS. One of the questions was, well, what was the process you used to georeference those paper plans into GIS? That seems like a daunting task to get those two systems to talk to each other. I think you might have mentioned it a little bit, but can you go into a little bit of detail on how you got those plans into your GIS?
Yeah, so let me clarify. So the georeferencing part was done during the data creation part, georeferencing the as-built so we could create any data that didn't exist already in our sewer and stormwater systems. The actual linking to Laserfish, what we did was, as we migrated the as-built into Laserfish, we used a naming convention that in Laserfish that we used in our attribution or in a field, within the field in our GIS data for each the sewer and storm drain naming convention. So in creating the attribution expression, we found that the search in Laserfish included the same exact link minus the as-built name or the name of the file. So what we did in the attribute expression was include everything minus the as-built name, and for each one, it would populate on click that name within that hyperlink or URL that would bring up in Laserfish. So hope that answers your question.
Yeah, that seems very powerful. And then a second question for you, Justin. How did you go about getting the as-built data from the developers? Did you find it difficult for them to put it into GIS from a computer-aided design system?
The as-builts were already on our network, submitted by the developers as projects came in, so they're already on our network. So
Great, perfect. Okay, and then another question is, how does the city go about the policy on sharing utility information with the public? Some of that information I would assume would be, confidential, but I think each organization kind of handles that differently. So do you have a policy in place on how much information you provide to public through GIS?
for City of Tulare, yes. We tend to share our sewer and stormwater information with the public. When it comes to water, and particularly wells and any water storage, any tanks, we try not to share too much of that. We do share it sometimes with a public records request. We can't really go around that, but we don't publicly share it on any open data sites.
Perfect. Great. I think Noah had a question from Bad Elf for some of the data accuracy items. We hear the terms mapping and survey level, recreation grade. Can you go through each of those and just give a level of accuracy that each one of those can provide in data collection?
Yeah, absolutely. Thank you for the question. So mapping grade is, we're going to say anything under a 5-meter bubble, right? So when you're driving down the road and you have your Google Maps on, and you see there's the small dot, and then there's the large dot, the large circle that's around it, that is the accuracy tolerance. So when you're driving on the highway, say 50, 60 miles an hour, your accuracy tolerance is going to be 50 meters, right? So that circle is going to be 50 meters big. But then when you get into a mapping grade receiver like ours, this is called the Battle Flex Mini. This does between 2 and 5 meters of accuracy. And then if you add what's called RTK corrections, which stands for real-time kinematics, which is basically like a base station on the ground that knows where it is in the world. And then it compares the sky view between your receiver and the base station on the ground. And this can get down to 10 centimeters. Now, our flagship receiver, the Battle Flex, it is a survey grade antenna. So that starts at sub-meter. So that's going to be between 30 and 60 centimeters. And then when you add those RTK corrections, then it goes down to sub-centimeter. And that's just depending on your distance from the base station.
Okay, perfect. And what's your experience there, Noah, on we know survey grade is very accurate, sub-centimeter in some cases. As far as data collection time, does it increase your amount of time it takes to collect that level of accuracy? And if so, is it manageable? Can you still get good data collection even though you're getting high resolution, high accuracy data?
Yeah, absolutely. The only issue is going to be your cold start time, right? So we recommend always turning the receiver on when you're on the way to the field, and then allowing it to see the sky on the way. And then once you're localized and you're moving around a local position, it doesn't vary very much. So maybe 2 to 3 minutes for that initial acquisition. But the only caveat to that is if you haven't started it in 3 months, it could need to download some data from the satellites, the ephemeris and the Almanac data, which it updates every 3 to 6 months. So that could take up to 10 minutes, but as long as you're using it regularly, you wouldn't ever run into that. So 3 to 5 minutes once you get to wherever you're going, and then minimal change when you move around. It might take 1 to 15 seconds to settle if you move between spots.
A lot better than it used to be, I would assume. Yeah.
Yeah, it's definitely come a long way.
Yeah, indeed. Justin, there was a question there for your capabilities, including extraction of utility networks from plan sets. Could you speak about that a little bit?
Yep. So all of our mapping is done based on anything you can see from an aerial or satellite image. So it has to be anything above ground. So we're unable to do like utility mapping in terms of like piping and stuff like that below ground. However, we help with the utility network, identify the utility network. So identifying 3D building heights. We can also help support encroachment analysis and things like that. It's just more above ground. It's less so, mapping anything below ground.
Yeah, I'm seeing a lot of that underground infrastructure 3D modeling taking hold, and it's a very powerful concept. I'm looking at that. Does any of the panelists have any experience building that 3D model, and what some challenges might have been on looking at it specifically in underground infrastructure? It's still emerging then, I take. Yeah, makes sense.
We're working with a vendor called Pix4D that is doing some interesting stuff in that space.
Great.
As far as like trench analysis and stuff like that. We haven't really done any underground testing yet, though.
Okay. Okay. This one is for Justin and Jason. I think maybe Justin Patananan. When developing your sanitary sewer utility network, how did you handle building the sanitary sewer manhole containments? And then second question, was that discussed and modeled in a pilot project for your data, or was it done after post-migration?
So I can take that one, Justin.
Okay.
As far as those utility network containments, the need for those need to be identified during the planning phase and incorporated. We recommend into the pilot project in relation to the utility network migration to make sure that if there are any issues with those or challenges, that those are hashed out during that pilot project phase. So any adjustments can be made before the entire network is migrated.
Okay, thank you. And then another question, what is the reliability of paper-based CAD drawings from a perspective of accuracy? I guess it would depend on the submission, on who's sending it in. Or
Yeah,
if you
I think it just comes down to accuracy. From a engineering drawing versus something that's taken from the field versus a GPS unit, there'll always be a slight inaccuracy, but I think the most accurate thing you can get is from a CAD file or a CAD drawing.
Yeah. And the follow-up question there was, how do you address the challenge to validate the accuracy of utility pipeline locations?
Actually, we've had some of our field crew remark on it when there have been some inaccuracies. There are boots on the ground, and they see things. They're the best eyes in the field, and we've had some discrepancies from time to time that have come up. So our field crew is our best source for any of that.
Yeah. So Justin, looking back on the whole process, since you had the strategic plan done and you're now implementing the recommendations, what would you say is your biggest hurdle so far in getting your GIS up and running in regards to the entire process you've undertaken there at the city?
So citywide, I think because not only do we cover our utilities, but we have our own PD and fire department. I think the city and the two services of the PD and fire kind of operate sometimes separately on the GIS front. Our police department has their own dispatch system and their own GIS system related to dispatch, and fire has their own needs in terms of mapping, pre-planning, and fire hydrants, flow tests that kind of operate on their own, and sometimes in relation with our water department. Sometimes it's a challenge to get all of those groups on one table, and kind of the transfer of GIS data is sometimes not as seamless as it could be. That's my main challenge, at least with this organization.
Yeah. So maybe the governance and the people involved tend to be some of the challenges on, early adopters and getting
Mhm.
people up to speed and training and that type of stuff. So
Yeah,
that makes
exactly.
sense. You bet. Great. And then there was one follow-up question based on those as-builts. So no plans to incorporate new as-built data from new developments. So I would assume Tulare is still growing and you're actually adding new locations. So
Yes, no, we do still get as-built and we will incorporate it. We're actually working on a phase 2 of our utility conversion that we will be mapping out all of our, bring us up to current. From the last 3 years, we are missing the last 3 years of development within Tulare. So we're trying to get our data back to current right now, as far as the utilities, as far as the sewer and stormwater. So yeah, those as-built are still important, and they're still important reference for us to go off of if in case the GIS data isn't correct.
yeah. And can you are your users able to take that information into the field and visualize that through mobile devices out in the field as well? And can you
Yes,
talk a little bit about that?
yeah, they're able to. Some of our staff has tablets. They can go into our ArcGIS hub through a browser. They can utilize field maps that contains this data. So yes, they can definitely go in the field and visualize and get information.
Perfect. Great. Well, thank you, everybody. I think we've answered just about every question that was brought up. We did end a little bit early, but I wanted to thank all the panelists for their time and effort to put this together. I know each of them would be happy to chat with you one-on-one if you have questions or if there was a topic that they touch on. You should have each of those panelists' contact information in the chat there. So feel free to reach out with them on a one-on-one basis and see if they might be able to help you in your initiatives moving forward. And also just be on the lookout on additional webinars. Different topics are always brought up in different GIS for state and local government solutions and various topics are always on the front with the webinar series. So be on the lookout for that. And also the recording of the session will be processed and posted to the entire attendee group. So with that, Jason, Justin, Noah, and Justin, thanks again for your time. Always good to see you all. So we appreciate you all as well. So with that, we'll go ahead and wrap up today's webinar and best of luck in your initiatives and look forward to chatting with y'all if need be in the near future. So thanks again.